Good day and welcome to this BricsCAD BIM training. Today we'll be looking at adding constraints and parameters. So we'll be making parametric models from scratch. To start, I will just explain some very basic concepts, and I'll do this just in an empty drawing. So just open an empty drawing and we'll just create a simple box. So I'll just use the box tool to create one simple box. We can apply parameters and constraints on our objects in our model, whether it be 2D or 3D, so that a certain parameter governs certain geometric properties. For instance, the height of this box or the width of this box, for instance. First of all, the constraints can be found in the ribbon in the Parametrics tab here. These are the ones we're going to be using, so the 3D constraints. And the constraints that are already applied in your drawing can be found in the Constraints and Parameters panel. This can be found on your right-hand side here. It's a little function. If you don't see it, you can again right-click anywhere in your ribbon, and under Panels, click Parameters and Constraints. So if I open this panel, obviously it's empty currently because there is no constraints in my drawing yet. I will start off with one of the most simple constraints, or at least easy to understand, and one of the most commonly used. It's called a distance constraint. So you can find here the distance constraint. Basically, if I click this, it will ask you for two entities or sub-entities. In this case, I want to use, let's say, this face here, and it will ask for a second entity. If we now click this face, automatically a distance appears between the two. I can already give it a different value, or I can just press enter. If I just press enter, you will see that this distance constraint now appears in my in my constraint panel. You see it has a certain expression. This expression is then solved into a value. So in this case, the expression is just a number, so obviously the value is the same. This will govern the distance between these two faces. So this means if I would change this value to, let's say, 5,000, you will see the distance between these two faces changes. Also, if I click this distance, you will see which faces are involved in this constraint. Now, actually, currently, so the distance between these two faces is governed by this distance constraint, but you will see if I animate it, this face is moving instead of this face. Right now, there's not really any constraint that governs which face should move. We can do this using fixed constraints. So let's say we want to actually have this face move instead of this face. What we can do is we can click the fixed constraint and say, okay, this face needs to be fixed, which means this face will always stay in this location. So now you see this fixed constraint appear here as well, which means now if I would animate this constraint and this distance constraint, you will see that now the other face moves. Okay, let's say we have a second box here, like this, doesn't really matter where or how. We can use a rigid set to make sure certain things stay connected or stay in the same place with respect to each other. So there's this constraint called rigid set. Let's say I put this face and this face in one rigid set, and I click enter. Now this means if I move one of those faces, the other face will move with it. So let's say I use push-pull. You will see the other face will also move with it. So these are some very basic constraints. And now we're going to be putting this knowledge into practice. So if we open in the Parametrics folder this mywindow.dwg, We'll see it's actually just a 3D window, but it's not parametric yet. So if we were to insert this window into a certain drawing, we wouldn't be able to change the width or height or the thickness or whatever. So we can solve this using constraints. First thing I'm going to do is you want to make sure your boundary detection is turned off, so just have your face detection on. I want to create two fixed constraints. And I'm going to use these two faces for the fixed constraints because actually we always want to have this lower corner of the window to be in the origin of the drawing. So that's why I will add one fixed constraint here and one fixed constraint here. So again, you see those two fixed constraints appear in the parameters panel. And now we want to make sure that this face, so the face of the subtractor solid, always stays aligned or stays coplanar with this face. So the outer face of the frame itself. Because right now they're not really constrained, they happen to be in the same face, but if I would now move this face here, it's not anymore in the same plane as this one. So what we want to do is we want to create a rigid set that connects this face and this face here. Easiest way to do it is if I hover over the side face of this subtractor solid. In the Select tab, there's a thing called Select Aligned Faces. If I click this, it will now also select the other face. So the other face that's aligned with this face. I have these two now, and I can put them in a rigid set. So I can either right-click and in the quad, under Constrain, click Rigid Set. Or I can use this rigid set option in the ribbon here. So I'll do the same for the other three sides. So select aligned faces and add rigid set. Select aligned faces and add rigid set. And again, select aligned faces and add rigid set. Now, this should mean if I now push-pull, let's say this face outward, that you will see the face of the other frame also move with it. So that's correct. Now you will see if I would click this, you will see the frame disappear. That's because of a setting called DM push-pull subtract, if I'm not mistaken. If this is enabled, you will automatically subtract geometry from other solids if you push-pull a certain solid. By default, it's turned on, but in some cases, this is not what we want. But yeah, this aside, we want to do the same actually for the inner faces of the frame. First, I'll just turn off my subtract solid. So I'll turn off this layer here. So we have a more clear view. We want to make sure that this face always stays coplanar with this face, so the outer face of my glass pane itself, so this face here. So again, we'll use the same technique. So again, I'll highlight one of the inner faces of the frame and click Select Aligned Faces. So we now have two faces selected. And again, create a rigid set. Otherwise, it will be possible to create a hole between the frame and the glass pane, which is not what we want. All right. So now we should have two fixed constraints and 8 rigid sets in our drawing. This means now if I would, let's say, push-pull this face over here, then also this solid is moved with it. So there's no interference between the two solids. All right. Now let's say we want to have a parameter that governs the width and the height of our window. So remember, I will do this by using a distance constraint. For the height of the window, I want to create a distance constraint between this face and this face. Again, I'll just press enter. And you will see this distance constraint appear in our parameters panel. I will do the same for the outside. Sorry, for the width, so the outside of this panel and this here, and create a distance constraint. And press enter. Now this would mean I should be able to change the height of my window, let's say if I animate this. But you see, actually there's something going wrong, because when I change the position of this face and the other face of the window, of the window pane, is not connected to it currently. So there's no intelligence between of how this face here should move when this one does. So for this reason, we'll also add distance constraint between this face and this face. So I'll just select them both, and again in the quad under constraint, click distance constraint and press enter. And we'll do the same for the three other sides. It's a bit of repetition. Press enter. So now we should have 4 distance constraints that all have the expression 40 millimeters. So this distance constraint, let's say this one here, governs the distance between these two faces, so the thickness of the frame on the top side here. Which means if I change my value to, let's say, 100, the frame thickness changes. I'll change it back to 40. But now, because the distance between this face and this face is always governed by this distance parameter, we should have no problem changing the height of the window. So if I animate this distance constraint here, you will see the window becomes higher and lower properly. Same goes for this one here. Or if I select these 4 distance constraints and I just animate them individually, see it works properly. Now we want to have these distance constraints basically saved in some parameters. So we want to create parameters that drive these distance constraints. So what we can do is we can create a new parameter, click new here, give it a name, let's say the height of the window, give it an expression, let's say 1200. By the way, the reason I'm giving this the name H is there's 2 possible values or possible names that are hard-coded. It's H and W for height and width of a window, which means when you insert your window into a drawing, you can directly change the height and width if you press Control. It will become more clear when you later insert windows, but for now I'll just give this the name H, and I'll create a new parameter with the name W for the width of my window, let's say 800. And now I can fill in these values or these names in the expression fields of these distance constraints. So let's say this distance here is obviously the height of our window, so I will give this the expression H. So it has the expression H and the value 120 centimeters. If I change this value to 1500, it will be changed here as well. By the way, these expressions don't just allow a name of a parameter, they can be actual expressions, so you can make sums, subtractions, multiplications, you can have some basic mathematical expressions in there. So I'll call this W. And then we'll create one more parameter that governs the frame width, the frame thickness, sorry. So I'll just call this frame thickness and give it a value of, let's say, 60. Now again, I can fill in here frame thickness. I will copy this word so I can easily paste it in the other fields as well. And now you'll see if I animate my frame thickness here, all four sides of the frame are changing thickness, so I can make a very narrow frame thickness, for instance. All right, so this already looks okay. Now the thing with this window is, let's say I save this window, so I will go to my components panel here and save this window in my Windows panel. So I will create a component. Let's call it, give it this name. Choose the Windows category. I'll just use the entire drawing. So click OK. If I now go to any other drawing, I'll just quickly model something using Quick Draw. I should be able to find this window in my panel here, my Win2. I can click it and just simply insert it in my drawing here. And in the properties, I can find these parameters that we made earlier in the parameters panel. So I can change the height to, let's say, 1200, or change the frame thickness to 10 millimeters. Now, the thing with this window is we can actually make a window of, let's say, 1, 2, 3, 4, 5, 6, 7, 8. We can make very weird or non-rounded off values. We can have a frame thickness of 11.563987.6 millimeters, which doesn't really make sense if you look at it from a manufacturing point of view. There's always going to be sort of fixed values that you can choose from, governed by design tables. So we can add these design tables in our window as well. For this, we'll have to open a mechanical browser. So the mechanical browser can be found here by clicking the Lego block. Again, if you don't find it, right-click in the ribbon and under panels go to mechanical browser. And you'll see the mechanical browser actually shows you the same constraints that we saw in the parameters panel. But it gives us a few more possibilities with regards to, for instance, design tables. Let's say we want to create a design table for the frame thickness. So we want to have some fixed values of the frame thickness. What I can do is I can create a design table. Currently it's still empty, there's no values in there, but the easiest way to do is to export it to a CSV file, manually change the CSV file, and then replace it by the CSV file you made. So let's say I'll just create this frame thickness.csv file on my desktop somewhere. If I now open this CSV file using, let's say, Excel, you may need to import the CSV file to be able to have it in separate columns like this. And basically, it shows us currently 2 empty columns. This is the name of the design table itself and the values that the design table can be. And this will be the values that this parameter frame thickness can be. Now in this case, we just have one parameter that's being governed by the design table. So it would be an obvious choice to have the same name for the design table values as for the frame thickness values. You'll see what I mean by that. So let's say we want to have a minimum of 15 millimeters frame thickness. and go by increments of 2.5, so like this, and we can go up to a value of, let's say, 45 millimeters. And I'll copy the same values to this side here. If I now just save this design table as a CSV file and go back to BricsCAD, I can replace this design table by the CSV file we just made. And now I can change the values I can choose from this list here. So you see actually the values that you see here are the same one as in this column here. And the values that our parameter frame thickness will take are the same ones as this column here. Now let's say we want to have also some fixed combinations for the height and width. Actually, I already made a CSV file for this. It can be found in the files where the models are itself. So if we go to the training starter files parametrics, there should be wh.csv file. I'll just open it as an example to show you. And here we see actually we have the values of the width, the values of the height, and then the possible combinations. In this case, I just gave it a name, 600 by 1200, for instance. If I go to BricsCAD and I can select these two parameters by holding Control to select them both, and right-click Create Design Table. So we'll create one design table for these two parameters. And now I can replace this design table by the one in this folder. You can create your own one, of course, as well. I'll just do this to make it a bit quicker. WH, and click Open. And now we should be able to see here this design table. I can choose from these values, so the same values as you could see in the CSV file. All right, now let's say I save this drawing again in my library. So I'll just create a new component, my Win3. And I go back to this drawing here. When I import this window now, or insert this window, you should be able to see that you can only choose from these values. So design table one, well actually I didn't really give them names. You can give them names, of course. So that's quite useful. Okay, so you may think that this parameterizing and constraining objects is quite tedious, and in fact you're right, it can be tedious, as we've seen with this window object here. That's why we developed a tool called Auto-Parameterize, which will basically constrain the object for us automatically. Let's say we'll just open this file here, this chair.dwg, in the same parametric folders. And you see this is just one solid, but there's no constraints to it whatsoever. If I open my constraints panel here, there's no constraints. And I could again constrain this manually like we did with the window, but actually that's going to take too much time. So I will do this using Auto-Parameterize. It can also be found here. First of all, yeah, so I'll click Auto-Parameterize and choose my entire, so this solid here, and press Enter. And you see in no time it created a set of constraints and parameters for us. Now obviously these constraints and parameters, they were made based on certain rules or assumptions. And of course not everything will be as we want it. For instance, I will see here that we have here these parameters, length xy. If I animate it, you will see that it's the width and the depth of the chair. So these two distances are governed by the same parameter, but maybe we don't want this. Maybe we want to have a separate parameter for width and a separate for for depth. So we're still able to change this, of course. We can still manually change our parameters. The easiest way to do this, according to me at least, is I will close the parameters and constraints panel. I will click one face, let's say the side face, and you will see this widget appear. It shows us that this face is involved in one or more distance constraints. If I click this distance constraint, so I click it, you will see there's 3 distance constraints with this face, one going to this leg here, one going to this leg, and one going to the other side of the chair, this length xy. You will see also now if I click this length xy, a panel appears. This is basically a subset of this parameters panel that we had before. That's why I closed it, because if you have it open, it will not appear here. And you see, so the width, this is the distance constraint, Cx. It's governed by the parameter length xy, which has a value of 500 millimeters. Now I want to create a new parameter that governs this width apart from the depth of the chair. So I can right click and click new parameter, and we'll call it width. And let's give it a value of, let's say, 400. And now I can change this expression of this distance constraint to width. Now you'll see if I open my parameters panel again, we have this width parameter. If I animate it, it will change the width of my chair. And now this length xy parameter actually only governs the depth of the chair, because we removed the connection between this distance constraint of the width and this parameter. So what I can do is I can just rename this parameter to depth, let's say. We also see, for instance, this P2 parameter here. If I animate this, you see it's the thickness of my leg, so I can just give it a new name. And this is the thickness of the seat, so I'll give it, again, a new name. And this length Z, you see it's the height of my chair, but you also see it's the height of this, but also changes the height of this. That's because this, the height of this seat, if we click it and click the, I'll just close this panel again. If we click this here, you see the height between this face and the bottom face here is governed by CZ times ratio 1. If I click this, CZ times ratio 1. Ratio 1 is just a parameter, a ratio value, and CZ is this length basically. So what it says is the thickness or the height of this seat is 0.54 times the height of the entire chair, so the backrest. But maybe we don't want to have this as a ratio, we want to have this as an absolute value. So again, what I can do is I can create a new parameter and call it height seat, and let's give it a value of, let's say, 400 millimeters. Now we can change this expression. Instead of having a ratio, we can just call it height seat. And if I go back to my parameters panel here, you see now if I animate this height seat, it changes the height of the seat obviously, but not the height of the backrest. And similarly also this length set will now only change the height of the backrest. So I'll just rename it to height backrest. Now because we The height of this chair or this seat was governed by a ratio. It's called this ratio 1 here. But actually this ratio 1, it's now become obsolete because it's not used in any expression. So what you can do is you can just right click and click clean unused variables. So it will, in this case, just remove ratio 1 because it's not used anymore. It's become obsolete. This is basically how you parameterize objects without having to do it manually all of yourself. You can start by doing auto-parameterize and then change still the expressions or the values to your liking. This was basically it for the parametrics and constraints section. Thank you for listening and good luck.